Okay, I have a confession to make.
Oh, yeah.
Last Sunday morning, I tried to make pancakes for the family, and it was a disaster.
Oh, the classic Sunday pancake failure.
Total crime scene. They
Yeah.
were burnt on the outside, completely raw in the middle, just rubbery.
Yeah.
But reading through the research for today, I think I see the problem. I wasn't failing at cooking. I was failing at engineering.
That is exactly the right way to think about it. I mean, the sources we looked at treat a pancake not as food, but as a fluid dynamics problem.
We talk about rhetorology, heat transfer.
Yeah, and chemical reactions. It's a whole system.
It sounds super intense, but the amazing thing is that it means we can stop guessing. There's literally an equation for a perfect breakfast. So let's start with the goal. We're not just heating up dough. We're trying to kick off a very specific chemical event.
We are. We're aiming for the Maillard reaction.
Which people always confuse with caramelization.
All the time. But they're totally different. Caramelization is just, sugar breaking down from heat. The Maillard reaction is way more complex. It's an interaction between amino acids from the protein in your eggs and milk and certain kinds of sugars.
And that matters because the temperature is different, isn't it?
Exactly. The Maillard reaction is what gives you that golden brown crust and all those incredible savory flavor compounds. And it really kicks into high gear between 150 and 160 degrees Celsius.
Okay, so that's our target. But here's the paradox I kept running into. For maximum flavor, you want maximum surface area for that reaction.
Sure.
But if you do that, you just end up with a crepe, not a fluffy pancake.
And that's the fundamental trade-off. It's all about the surface area to volume ratio. You need the surface for that delicious Maillard flavor, but you absolutely need the volume for the fluffiness, for retaining moisture.
So if it's too thin, the heat just blasts right through and dries it out.
Instantly, before the internal structure can even set.
So we're looking for a kind of geometric Goldilocks zone.
And the math, it actually points to an optimal thickness. It's about 8 to 10 millimeters.
So roughly a centimeter thick.
Yep. That gives you enough time for the outside to perfectly brown while the inside cooks through and traps all that steam, creating those wonderful bubbles.
But you can't just pour batter and tell it to be 1 centimeter thick.
Yeah.
So that brings us to the batter itself. I saw this term in the papers, the viscous gravity current model.
Which is a very, very fancy way of asking, how far does the blob spread out before it stops?
Okay.
You want a batter, that's what we call shear thinning.
Which means it flows easily when you pour it from the ladle, but then it sort of thickens up and holds its shape once it hits the pan?
Precisely. And you don't need any lab equipment to test this. The sources have a really practical benchmark.
Oh, good.
You take a standard ladle, so about 70 milliliters of batter, and pour it. It should naturally spread to a diameter of about 10 to 12 centimeters.
And if it spreads wider, it's too thin, so add a bit more flour.
Right. And if it just sits there in a lump, it's too thick, add a splash of milk.
You're literally engineering the viscosity to create the right geometry. It's brilliant.
It is.
Now, before we actually put this perfect geometry on the heat, we should talk for a second about the tools that help optimize our own lives. This deep dive is sponsored by Embersilk.
And if you need any help with things like AI training, automation, or software integration, they are the ones to check out.
Or even just figuring out where AI agents could actually make an impact for your business or, even your personal life.
Yeah, that's a big one.
Seriously, seeing where AI can have a real effect is huge. Check out embersilk.com for your AI needs.
Okay, so back to the griddle.
Yes, we have our batter physics sorted out. But the heat setting, that's what caused my Sunday disaster. High heat seems right for a crust, but it just burns. Low heat takes forever and it dries out.
The magic number is 190 degrees Celsius. That's 375 Fahrenheit.
That is very specific.
It has to be. At 190, you're hot enough to start that Maillard reaction almost on contact. But it's not so hot that you char the outside before the heat can travel to the center of that 10-millimeter pancake.
Most of us aren't cooking with infrared thermometers, though. I did see this water droplet test mentioned a few times.
Yes. It works because of something called the Leidenfrost effect.
Yep.
If the pan is too cool, a drop of water just sits there and sizzles away. But if it's at that perfect 190-degree range, a tiny cushion of vapor forms under the droplet.
And it dances.
It dances. It skids around the pan like a tiny air hockey puck instead of just boiling off. That's your signal. That's the green light.
Okay, batter is down on the perfectly heated pan.
Yeah.
Now, the final boss, the flip. I have always heard you should only flip once, but I figured that was just an old kitchen myth.
Nope, it's physics.
Of course it is.
You are carefully building a network of bubbles inside. The signal to flip is when the bubbles that form on top pop, and this is the key, stay open, they form little craters.
And that tells you the heat has made it all the way to the geometric center.
And the structure is stable. If you flip it back and forth, you're just compressing that delicate network you just engineered. You squeeze all the air out.
And you get a rubbery tire.
If you get a tire, flip it once. Commit to the flip.
It really is just an equation then. 190 degrees Celsius, 10 millimeters thick. Check for the Leidenfrost effect. Respect the bubbles.
When you control the variables, you eliminate the need for luck.
I love that. So the big takeaway is, next time you're in the kitchen, don't just cook. Engineer your breakfast. We'll have links to all the sources in the show notes. But here's a final thought for you to chew on. If surface area is truly the key to flavor, at what point does a waffle, with all its nooks and crannies, become objectively superior to a pancake?
Now that is a delicious equation to solve.
If you enjoyed this deep dive, please subscribe to the show. And hey, if you can, leave us a 5-star review. It really does help get the word out. Thanks for tuning in.